Earth's structure and composition. Earth is a complex planet with a layered structure and diverse composition. It can be divided into several major layers based on their physical properties and chemical composition. From the inside out, these layers are the inner core, outer core, mantle, and crust. Inner core. The inner core is the innermost layer of Earth, located at the center. It is primarily composed of solid iron and nickel due to the extreme pressure and high temperatures, which can reach up to 5,500 to 6,000 degrees Celsius. The inner core has a radius of approximately 1,220 kilometers. Outer core. Surrounding the inner core is the outer core. It is a liquid layer composed mainly of molten iron and nickel. The outer core has a thickness of around 2,270 kilometers. The movement of molten iron in the outer core generates Earth's magnetic field through a process called the geodynamo. Mantle. The mantle is the thickest layer of Earth, extending from the bottom of the crust to the outer core. It accounts for approximately 84% of Earth's volume. The mantle is primarily composed of solid rock, rich in silicate minerals such as olivine and pyroxene. It is divided into two main sections, the upper mantle and the lower mantle. The upper mantle is relatively rigid, while the lower mantle is hotter and more plastic in nature. Crust. The outermost layer of Earth is called the crust. It is the thinnest layer, ranging from 5 to 70 kilometers in thickness. The crust is composed of various types of rocks, including granite and basalt. There are two main types of crust: continental crust, which forms the continents, and oceanic crust, which underlies the ocean basins. The continental crust is thicker but less dense compared to the oceanic crust. Overall, Earth's composition is primarily composed of iron, oxygen, silicon, magnesium, sulfur, nickel, calcium, and aluminum. These elements combine to form various minerals and rocks that make up the different layers of Earth. The dynamic interactions between these layers, driven by heat and convection currents, contribute to geological phenomena such as earthquakes, volcanic activity, and plate tectonics. Here are some additional details about Earth's structure and composition. Lithosphere. The lithosphere refers to the rigid outer part of Earth, which includes the crust and the uppermost portion of the mantle. It is broken into several tectonic plates that float on the semi-fluid asthenosphere below. The interaction between these plates at plate boundaries gives rise to various geological phenomena such as earthquakes, volcanic activity, and the formation of mountain ranges. Asthenosphere. The asthenosphere is a semi-fluid layer beneath the lithosphere, extending from the upper mantle to a depth of about 660 kilometers. It consists of partially molten rock that is more ductile and can flow over long periods of time. The asthenosphere plays a crucial role in the movement of tectonic plates. Moho. The Mohorovičić discontinuity, often referred to as the Moho, is the boundary between the crust and the mantle. It was named after the Croatian seismologist Andrija Mohorovičić, who discovered it. The Moho represents a significant change in seismic wave velocities and marks the transition from the brittle crust to the more plastic mantle. Composition of the crust. The composition of the crust varies depending on whether it is continental or oceanic. The continental crust is primarily composed of igneous, metamorphic, and sedimentary rocks. It consists of a variety of minerals, including quartz, feldspar, and mica. The oceanic crust, on the other hand, is mainly made up of basalt, a type of volcanic rock rich in iron and magnesium. Transition zone. The transition zone is a region in the mantle located between the upper and lower mantle. It extends from a depth of approximately 410 to 660 kilometers. In this zone, there are mineral phase transitions due to the increasing pressure and temperature, causing changes in the mineral structures and properties. D layer. The D layer is a region found just above the core mantle boundary. It is named after the sharp increase in seismic wave velocity observed at this depth. The D layer is thought to be associated with the partial melting and convection of material at the base of the mantle. Mantle transition zone. The mantle transition zone is a region within the mantle located between depths of approximately 410 and 660 kilometers. In this zone, there are several mineral phase transitions due to the increasing pressure and temperature. These transitions result in changes in the mineral composition and properties, which can affect the behavior of seismic waves passing through this region. Low velocity zone. Within the upper mantle, there is a region called the Low Velocity Zone, LVZ, located between depths of approximately 100 and 200 kilometers. The LVZ is characterized by slower seismic wave velocities compared to the surrounding mantle. It is believed to be associated with elevated temperatures, partial melting, and the presence of fluids, which can contribute to the overall plasticity and deformability of the mantle. Plumes are hot, upwelling regions of mantle material that rise from deep within the mantle to the Earth's surface. They are associated with volcanic activity and can give rise to hotspot volcanoes such as the Hawaiian Islands. Plumes are believed to originate from the core mantle boundary or the lower mantle and can penetrate through the mantle transition zone and into the lithosphere, creating chains of volcanic islands or seamounts. Mineral composition: Earth's mantle and crust are primarily composed of silicate minerals. Olivine, pyroxene, and garnet are some of the common minerals found in the mantle. In the crust, various minerals such as quartz, feldspar, and mica are abundant. Different minerals form under specific pressure and temperature conditions, contributing to the diverse composition of Earth's layers. Core mantle boundary. The core mantle boundary is the boundary between Earth's mantle and the outer core. It is located at a depth of approximately 2,900 kilometers. The core mantle boundary is marked by a significant increase in density and a change in seismic wave velocities. The exact nature of the processes occurring at this boundary is still an area of active research, but it plays a crucial role in Earth's geodynamic processes. Isostasy. Isostasy refers to the equilibrium or balance of Earth's crust and mantle. It is maintained by the adjustment of different parts of the Earth's lithosphere to variations in the thickness and density of underlying materials. Isostatic adjustments are responsible for phenomena such as post-glacial rebound, where land that was once depressed by the weight of ice sheets gradually rises over time. These additional details provide further insight into the complexities of Earth's structure and composition. Our understanding of these aspects continues to evolve as scientific research and exploration uncover new information and refine existing models.